Long time since I have done this talk. I'm absolutely not sure about all the demo. So I hope it will went well. So hi everyone. We're here to speak about process, container, virtual machine, everything. Um, First I say hi. Oh, sorry. First I want to say hi. My name is Quentin Adam, and I have absolutely unpronounceable Twitter handle, which is great because it will be available everywhere, except where someone stole it on Pokemon Go. So if you find someone called Wax on Pokemon Go, just send it to me. I want my handle back. Um, in the day-to-day work, my job is something called Clever Cloud. So I'm leading the company, and basically what we are doing is keeping your application online. So basically, as a developer, you just git push, and we deploy. And after the deployment, we manage the whole application sustainability you need for monitoring, backup, security update, auto scalability, auto healing when application fail, everything. So it's very interesting project because we do a lot of cool stuff, and we meet a lot of things because we learn a lot about good things, bad things. We have customers in 2,600 cities in the world now, and big banks or insurance or French TV network or Airbus or this kind of very big company, and very small company, $5 per month user using Clever Cloud for many things like fan sit of Harry Potter, or I don't know, someone who grow plants in Greece, or there are people in Poland using our service to streaming cult from a peers with the Verge appear and everything. So we have so many customers. It's very fun, and we learn a lot of things during all the support we give to them, and we try to give back to the community, writing blog and giving post and everything. So why we will speak about virtualization container and all the other technology. Um, to be honest, the first idea of this talk went because a lot of people was saying a lot of very stupid things about containers when Docker pop-ups, and I think, okay, these people need to be updated because they obviously didn't read the last 10 years of changelog of the Linux kernel, and seems they need to understand about all of this is working. So basically that. If you're thinking at the beginning of computer science, at the beginning we have very, very large computer, like large like this room, and there was very small capacities. And developer write a software, put it in the computer, and the software begin to be executed, and go to the end of the software, remove the software, getting the answers you want back from the computer, putting another software inside it. Then what's happening is we will be able to run the software on just a single hardware. So basically, one computer and one software. Then we will be able to have computer more and more powerful and be able to execute some programs in only one hardware. So the idea was, okay, how to handle that Bob and Rob will write software, they all will be running in the computer, and they need to not have problem executing in the same hardware. And that's why we create operating system. Because one of the major work of the operating system is doing something very important, which is the process scheduling. Oh, sorry. The process scheduling. Process scheduling is the ability to say, okay, this process is executing, we will start this one, pause this one, everything. Do you remember a few years ago the big war between System 5 Init and System D? Okay. This is exactly the point. It's the init process. Init process is the first process to start inside your computer. And the init process is about to say, just start this process or do not start this process and everything. And it's a core of the operating system. It's the ability to manage the few process. And for this, Unix was very interesting about that, because it's creating the way the process are designed now. The problem with that is, years ago, we end up to the spaghetti ops management. You know, like you have this server and you start it a Tomcat with another Apache with a mod GK, which is able to speak with a Tomcat, and there is also a database here. Oh, and don't touch to this. This is just a blog of the company, but it have to be in the same server for some obscure reason. You know, this kind of server where nobody wants to touch it because it was really complicated to go inside it, because it went up spaghetti with a lot of configuration, similar software launching with different configuration. You know, this kind of server, nobody wants to touch it. So we're starting asking ourselves, we need to unlink the capacity of the software to the hardware and be able to use the hardware for run many software without to have a problem of isolation. It's basically what does process. When you start a Windows 89, 99, 95, I think, you have something with a process which is, you go on a kernel which will not protect a process from another one process. And if you want to write inside the memory of another process, you say, okay, that's fine, doing it. And you have a blue screen of the death. No, all the operating system are managing process to be sure that one process cannot write inside the memory of another process. It will be a bug. And that is the important stuff about isolation. If you're going to inside the Linux, and I'm doing this, okay. Still reading it? It's okay there? Okay, perfect. If I'm doing this, I can see there is many process running on my computer, and the process cannot go to the memory of other, so that's fine. But the problem is we need more isolation between process, because we don't want one process can crash another just writing some file into it or doing some stuff. In fact, isolation is a problem of many things in the same time. First, isolation is about software dependencies. Who have played with the strange game with aptitude, where you want to do aptitude install, and it show, okay, I can uninstall 400 package and install another 400 package and it will be fine. You know, this kind of, I have a problem of version of libxml2. This kind of stuff, very weird, happening with the software dependencies management, where one software needs libraries inside the system, but you don't want all the software share the same libraries, because they will be at the same level for all. This is the first problem software isolation is about, managing the dependencies. The other problem is the security. You don't want a process can be accessing another process, which will be complicated. And the other one is the hardware resource access. You don't want that the application to manage holidays of the people working at the company being able to eat all the CPU power and on the website of the company. And these 3 points, the software dependencies, the security, and the hardware resource access, are the 3 points of isolation. So at the beginning, we start with something called root. Root have been invented in the 80s, and it's something very simple, in fact. We are in Unix. In Unix, everything is a file, process, memory, device, everything. So if we are able to just lie about what is root, you know, the first, the root of the file system, we can change everything about how the process will interact with. It's exactly what we can do is, for example, we'll have a Node.js application. So I have a Node.js application there. And this Node.js application have, on purpose, a bug inside it. So I can execute something with just adding an headers in the HTTP request. So if I'm executing that, I can see there it execute date. And the problem with that, if there is a file there, I can, for example, create a file inside root, which will be, I don't know, something like that. And if I see, there is a file. So basically, with this kind of break, I can compromise the entire system. If I'm using Shroot is interesting stuff, because if I go to there, I have write many files to be able to mount all the stuff I need to the Shroot to be done. So I need to mount the procs, the sys, the level, the bin. Yeah. So I have mounted everything I need on this place. I need to be root to do the mount. But anyway, since then, I can start a Shroot process inside it. So for example, if I want, I Shroot there, and if I hit slash, it thinks that slash is no Shroot, which is really interesting, by the way. So it changed the way Shroot file system have been done. And if, for example, I'm doing a Shroot with Node, I have so me, I'm not inside the Shroot. I'm inside the root file system, but the process, if we're looking at it, is not Shrooted. The Node process is not Shrooted inside its own root file system. And if I try to, sorry, if I try to touch some file here, sorry, if I try to write some file in slash, it will not be on root, but on the base file system, which is great. Seems we have finally find a way to isolate application. Yes, but no. In fact, Shroot have several problems. First, it has a very weird relationship with root. Second, it's very easy to break out. Just giving you an example. Imagine I Shroot inside this. So there, I'm in Shroot, okay? But the point is, reading the mount, I can see I'm in the Shroot file system. So if I want to just Shroot myself into the first place where I'm coming from, I will be unshrooted. And I'm unjailing myself, and I'm now inside root, which is really bad. And this kind of fail can conduct in other miscomprehension, because, for example, if you're not able to see as sudo, for example, you are in a shrooted environment, you will check the shrooted environment secret file, which leads you to an ability to have a privilege escalation. Instead of protecting the operating system, you will have a problem. And there have been several problems with su and sudo around container just for these reasons, because this software need to know that. But it's cool for our dependency management doing well, and it's cool to to manage some stuff there. Should have been the solution for years, but as it's complicated to watch around all this stuff, we're starting to building things we call the jails or the containers. Maybe you have heard about OpenVZ, Linux VS Server, or Elixir, and everything. It's long time software used by many peoples before Docker, runc, RKT, and everything. And they have all the same runtime. It's a Linux kernel. When you're launching Docker, Docker will not enter the process you have. It's only making calls to the Linux kernel, and it's very simple. And by the way, this is why Docker is not writing a low-level language. Yeah, pop info. Go is not a low-level language. It has a garbage collector and a runtime. It's the same thing that JVM for Java, for example. It's exactly the same thing that Java 1.3, if you want my personal think about that. But what you need to understand is you can write a container engine as nearly everything because it's not the runtime. The runtime is Linux. And all the containers are using exactly the same stuff. It's three components of the Linux kernel. First, something called the Linux namespace. Namespace have been introduced in 2002 with the namespace required for Shroot, and it's a working implementation. But in 2013, we have a very big update on namespace. Just to understand clearly what namespace is, imagine this as a map of mask. In a namespace, you say this, will be for this process, for the process tree, to be totally honest, this. And in the way it's interact with your system, it's just changing the name of something for a process tree. So if you go inside, for example, when you are on Linux and you go on /proc, you will see every process running on your system. And if we're going to some of the process, I don't know, this one, for example, you can see there is many information you can find here. For example, the command line used to launch it. This one is not launching with the command line. But it can be, for example, where is the executor, you can find the environment, you can find many things in this. And you have something called namespace. And the point with that is the namespace are different between their usage. So you have the MNT namespace, which is Munt, which is exactly what we just used with root. You have the PID, so you can change the PID of a process in the majority of cases to give the PID 1 to someone. You have all the network name and everything. You have the ability with IPC of controlling time, with ETS controlling time, APC I do not remember, and you can also have user swap on PID. So you can reconfigure everything the process see in the system to another thing. Okay? And this is the way the containers are working. Oh, gross. The other thing containers are using to work is the Linux cgroup. Linux cgroup is not a security feature like everyone is pretending. Linux cgroup is a way to have hardware quota isolation. So you can have quota of what a process do on the Linux system. It's not working well. I mean, the kernel is the judge and a party of the deal. So it cannot be good, It cannot really working. It's a long work Google have been done in the kernel since 2008 to be sure that they will be able to control for Borg the way that every process interact. The version 2 is way more complicated than the version 1, but doesn't solve every problem we have. And the other party used by the old containers are Linux capabilities. Basically, Linux capabilities is the ability to not give SUID to every binaries. It's breaking the right of the SUID to many components to not be able to give all the rights to one programs. And with this all three, you have the Linux containers. So the important point to understand is Linux containers are just process. At the time we see if it's working well. It's not working because it's not finishing the download. Be complicated to prove myself there. I will see what I have as images in my Docker. Oh, great. Can you find Alpine quickly, please? Okay. Will be complicated. Find a great ID, find a great ID. If I cannot have Alpine quickly, I don't know what I can do quickly more than Alpine. Run, please. Okay. It's waiting maybe from there. Maybe if I cut it, it will be working well. Yeah, great. What you need to understand is it's readable for everyone. Okay, so as I said, it's only Linux process. When I say it's only Linux process is as containers are made of binary, when you're using a container inside an operating system, it cannot be native to anything other than Linux. We will speak about the Windows container later. But the point is, when I say that is when you use Docker for Mac or Docker for Windows, you're not using actual native version of everything. It's using virtualization because you cannot have something like this working without the virtualization. And if we're going to look at this, inside Mac, you just have to open the TTY of your Linux container, of your Linux inside the system. And if you're looking at it and ask yourself for who are you, it's Linux Mobi. So you are doing some virtualization stuff here. And the point is, admitting, so I'm trying something. Docker run Alpine top. It will not work. So there I have one top inside a container, so it doesn't see the other stuff because of the namespacing, and it's running there. But if I am inside the Linux on top of it, and I'm doing a pass aux, and I'm looking for where is he? Oh shit. Can I have some? No, already no. So if I'm looking at where is my top, is you can see the Linux container. This system is working somewhere there, so we will see the top very quickly, and the top is here. The top is running as a process inside your Linux, so it's running and it's running root. The demo I do usually is using a full database using Elasticsearch, Cassandra, everything. We will see if it will be able to download everything and be ready later. But you will see that Java is running root and everything. So when you say containers, everyone see a very giant box of iron and things trapped in there. But it's not true. It's just fucking process. Okay? Just the same thing that you have your Apache, PHP, something inside it. And what you need to understand is isolation has some side effects. When I say side effects is when you use something like isolation, you want to be sure that everything you have is under control. Each process launched on Linux are able to be represented as a file. And the point of a process represented by a file is if a process is open, you will open a file. And the number of files you can open in your Linux is a limited resources. What will be happening if we open too many files? Let's find out. It's just a for loop with Ruby. And I will need to download Ruby. Oh, fuck. Seriously, 20 megabytes of bullshit just to have a for loop. Okay, it's getting all the data. And I will do the demo about this later. I hope there is only 20 megabytes of binary somewhere. The other part with the isolation of side effect is if the whole operating system have some very special resources, you have another point, which is the containers and the entropy. Every container shares the same Linux kernel, okay? So every container shares the same source of entropy. Entropy is a random generator. Random is used by crypto. If you are smart enough to be able to drain the random, the entropy source of the machine, you will be able to determine which will be the next random inside the container in your neighborhood and break all the encryption on the whole container is the virtual machine. So we have a big problem here, which is we are not being able to isolate the entropy of every container. But we have numbers of other possibilities to fail. For example, when you use dirty code, it's a fail on the Linux kernel. You will be able to find another way to get into your hardware anytime. So basically, the whole operating system is fighting against the idea of having real isolation between process because it has never been designed to do that. And I'm not speaking about problem like, what I am speaking about is the same problem for Rocket, for systemd spawn, for Docker. It's have all the same problem. You can do your own container system with Bash if you want, or PHP. It will be the same problem. The problem is on the runtime. The Linux kernel is not able to give you the amount of securization and you need to do that. It's still downloading. Ah, sure. We have a big fat 40 megabyte layer. Cool. The other point is about the respect of Linux philosophy. When you're using, first, there is a problem of respecting Linux philosophy in a way. So when you're using RKT, for example, it's respect Linux philosophy. It does only one thing and delegates the managing of the process to systemd. But when you're using Docker, Docker is the same binaries for server, for client. There is also a reverse proxy inside it to download stuff, and you decide to manage process. And one of the problem with Docker is it's managing process exactly like it was PID1, but it isn't. And you know there is all this war between Docker and the people of systemd, because Docker don't want to expose to systemd what container you have launched. So you have two acting managing of process inside your container. And inside the container, the first process you launch is PID1, as we stopped earlier. The problem having multiple PID1 is PID1 has one job, starting and stopping process. Okay. But it have another job, cleaning zombie process. So basically, you can have a system with a lot of zombie because nobody is cleaning it. Because bash is not an init scheduler. It's just your bash. And now you can have many other problems like try to connect your GConsole, for example, to a process we think is PID1. It will never do that because it's designed to not do that. The other problem is, when you see Docker, it's good because you will have the same binaries from the computer of the developer to the server into production. I'm pretty sure you're developing using Java, for example. And to be honest, when you're doing some Spring application, the version of the JVM himself is not really important. So the version of every binary inside the JVM, you don't care. But the version of the kernel interacting with the glibc, you all know what is glibc. glibc is the heart of the system. It's a standard C library. So it's very, very important. Using an untested combination of kernel and glibc seems to me far more dangerous than using another JVM you don't know, because it will be interacting at very low level specification you absolutely don't know. So this weird interaction between the kernel's operating system and everything. Oh, you don't know. It's a new slide. And no, thank you very much. So as you share the kernel, the point is you can have many problems to fail. If we go all in the restaurant after, we will all eat in our plate. We will not share the plate because it will not be safe. So when you're using Docker, just remember that. You're using the same kernels as other container. So is it acceptable to use the same kernel than them? It's the only question. And now all the Docker marketing is about to make more against VMware and not using virtual machine. Remember, it's absolutely different in terms of security, because if this process container just take down, it will have the old process container of the old process virtual machine taking down with the same kernel, because they share the kernel. So that's why, Docker is ready. Oh, absolutely not. Um, that's why at the beginning we continue to think. Yeah, about unique kernels. Everybody is talking to me about Docker to using with unique kernels. The point of unique kernels is having your application being an entire operating system with a kernel himself. So you cannot have a unique kernel inside Docker because there is a kernel. It's a kernel of the Linux machine. So if you want unique kernels, you have to use virtualization. Okay? Seems clear or not? I really don't get it. This is because they buy a company of unique kernels. They buy the company of unique kernels because it was the guy able to write driver to be able to do the good virtualization they make for Docker for Mac and Docker for Windows. It's this guy writing the driver and everything very beautiful we have to do the stuff. And speaking about other complicated stuff, it's monitoring. If you're using Docker, you will have to monitor somehow. And you need to find a way to monitor your container. Good luck with that. Every monitoring system has been designed to monitor an entire system and not only one process from inside a jail. So you will have a lot of problems there. That's why at the beginning and before Docker came, we all think it was not a great idea to use container in production. Instead of that, we continue searching. And what we're looking for? The emulation. Emulation is something interesting. Have you heard about QEMU? Dolphin to play to GameCube games, something like that. Cisco, okay. Emulation is the ability to just emulate a processor which actually doesn't exist. It's only code. And put kernel on top of it and simulate there is hardware. The hardware is not actually existing, but you fake there is a processor running and a kernel on top of that. And emulation is the way we're using to have Dolphin and everything. And QEMU have been done for that. It was very slow because you emulate a lot of stuff. In the same time than people working on that, there was Xen. Xen is something called paravirtualization. Paravirtualization is a very complicated word because everybody is using it for different meanings. Don't rely on this. And the idea of Xen was to just have a very small software booting the hardware, modify the kernel to be able to make it running as a process of this first system and be able to launch an entire Linux system within the kernel. It was not real virtualization. It was the ability to fake virtualization, but you have to patch your kernel for this. And it's this way Amazon Web Service was created, for example. And then something changed everything. Intel come with new set of instruction for the CPU called VTX. VTX is something very clever designed by Intel. It's the ability to run multiple operating systems in the same CPU without them to notice it. It's a context switching inside the CPU to be sure that the operating system it's not conscious that another operating system is there. And at the beginning, what's done, it's an absolutely separation of software inside the same CPU. And it was really clever. It was in a 203, and the absolute separation of software, it's guaranteed by the hardware. So you're safe. Using this, we have access to the hardware determining what we can do for this. At the beginning, Intel think that we will have hardware with one CPU and, for example, 20 network cards to power up everything. And that's why was interesting with that. So it's not happening like that. Basically, we give the network card to one of the operating system, and after is powering a switch inside a virtual switching system inside the hardware. But at the beginning, you can say to the processor, just give this hardware or give this hardware or give this hardware to every process exactly inside the processor. So what is interesting is you can have the entire operating system and not a part of the operating system without the kernel. You can have the entire operating system running, which is great in terms of isolation, VM perspective, and everything. You have the software dependencies, you have the security because it's guaranteed by their hardware, and you have the hardware resource access because it's guaranteed by the hardware. So it seems the perfect solution. Then it fails because many solution lack of performances. We'll think virtualization is slow. Nobody? Weird. Virtualization is not slow. Virtualization is, in fact, pretty fast. When at Clever Cloud, we ask a virtual machine towards the orchestrator, and the time it's up and running, it's only 7 seconds. 7 seconds to boot a virtual machine entirely. Because we just light the whole process. It's very quick, in fact. The point is people thinking the performances are very bad because they're using some software like VirtualBox, for example. And the problem is not VirtualBox itself, but to render graphic for VirtualBox, they have to emulate a graphic card because they cannot give to the virtual machine the graphic card of your computer. You're using it already. So they emulate a graphic card, they capture the old pixels, they give it to you. So it's very slow, for example, just to build the rendering, not the CPU part. And what you need to understand that is performances have to be measured, to be precisely measured with scientific approach. It cannot be, I feel that slow. Because rendering UI is a complicated stuff. And maybe it's not interesting. And more is, what is your bound? Is your program lacking of RAM? If so, I'm very sad for you because no, RAM is pretty cheap. So you don't really need it. Maybe your program is lacking of CPU and you burn it. I don't think so. Because CPU is cheap today, and majority of the CPU we have in our thousands of servers at Clever Cloud are very low, used by thousands of virtual machines. So why? Your application is slow today because of I/O. I/O is the ability to write on the disk or to read on the network. And you're thinking about that with writing web application, we actually get information from the network, go to a database on the network, the database is searching on the hard drive, which is another I/O, and get back to the application through the network, and you get back the information. But the CPU on that is very low solicited, because it's very simple for them. The problem of performance is for many people is the I/O. And the problem is using containers, you're using user land capability to proxy the I/O and slow down the entire process. Using virtualization, you can use solution like VirtIO, who actually give you the exact same performances on the I/O than the other stuff, which is great. Yes, I know. There are many benchmarks on the internet saying, yes, but Docker is faster than QEMU because blah, blah, blah. And if you're looking at the benchmark, there is a small hint saying, using host mod. Using host mod, say, using the mod where there is absolutely no security and I bypass everything using to just distance the I/O from everything. So it's not something you will use in production. I can do this kind of stuff too. Yeah. Okay, having your native software is more quick to have not native software. Cool. But the point is, I/O is the important stuff. So the hardware allocation is the most important stuff and how to use it. And if you're looking at that, is the more big constraints you need to understand. Where is it? If you're looking at, for example, we will connect to KVM servers where we have many servers. Inside it, we can run a lot of VM. And if I'm looking at it, oh, there is many process. So we have all this KVM stuff, and we can count it. And when we count it, there is there is many process. But if I'm doing pass aux, and I'm looking, for example, for Java, which is kind of application running on that, I will never find the process because the hypervisor and the host are totally separate, and they cannot look at what is inside the virtual machine. So the isolation is real and provided by the system. So we will pass on that because we have no time. If you want to go on all this stuff, which is really interesting, you need to learn the Linux low-level dark magic. And when I say Linux low-level dark magic is, for example, my friend Alpine Linux. We all use Alpine Linux because it's so small. Alpine Linux is so cute. All they can do is so small. It's basically it's very exciting because we all using Alpine Linux not because it's a good idea to have small binaries. We don't care about having small or fat binaries. Really, I don't care. But only because we all test the system on our laptops and we have a shitty Wi-Fi. So basically, we're making the important choice of which Linux distribution we use, not because of some quality, but only because we have shitty Wi-Fi. Great architecture design pattern. But anyway, all they can do to have small Alpine system. No, they didn't strip everything you don't need on Linux. What they done is way more radical. They have removed the glibc to replace it with something they've write on their own called muzzle. There are two people writing code on it. And if you go on the Alpine package, there is only one guy maintaining all the package. Bus factor 1. And actually, using Alpine, you're switching from the glibc to another thing which absolutely no one tried with it. Do you think that the people writing MySQL, PostgreSQL, PHP, Java is trying against muzzle or the glibc like everyone does? So actually, when you're using Alpine in production, you're not doing some stuff we say like it's the same binaries from the developer stuff to the server stuff. You're actually introducing randomize the heart of the operating system. Hey, fuck it. It's nightmare. Don't do that. I play with Alpine all the time. I never build it in production. Okay? It's very complicated. Oh, fuck. Why? Where we will be? Something like muzzle 119. And what you need to think is about the dependency monolith you have. For example, if you take all the dependency layer, do you really need to have a very big dependencies to everything on the hardware and on the operating system, or can you just be dependent of your build system? Do you really need to choose all the binary or not? And as a developer, do you really update the library you use at dependencies? So you will be able to update the operating system. So what I want to say this is just like, be careful about giant binaries everywhere. And particularly if you're using at, I will not be impressionated with you. If I say so, you will do what I want. And particularly, you can use container for production, but doing it with ops. When we say DevOps, is not developer doing the job of ops. It's say working together. And just remember that if ops are annoying with all the question at the beginning of something go in production, is because if there is a fail, they need to understand. If you say just shut up and put this Docker in production, they will not learn how is it working. And they will learn when there will be the first fail. And you don't want anyone to learn at this time because you just want it working. So this is the majority problem you have with this kind of approach. So you need to remember that. So please remember to end this talk. Containers are not virtualization machine, not light VM, not anything like that. And they are not metal box where you can put something inside it. Container isolation is weak. Don't run software of people who don't know those people in the same Linux. It's exactly the same thing that doing PHP mutualized for everyone with the help of everyone is building his own binaries. If you really want to do some DevOps cool stuff, just learn how Linux works. Learn how systemd works, read the Linux kernel, changelog, everything. You can do fun things using container. And last of everything, there is no panacea in IT. If you want to automate all the IT, it will be not only Docker, but a full set of program. Do I mention that Clever Cloud sell IT automation? And if you think that a product can solve all your problem, you will be disappointed because it never happens. So thank you very much for listening. Why there is absolutely no oh fuck at the end. Oh, but funny thing. Okay, so the real coupon is not this, but this one, which is more related to GeeCON. And thank you very much. I have cool stickers, and I can take a question or two. Yeah. And I can take a question if you want. There is some question. Yeah.
Thank you for the presentation. What would you say is the #1 advice for people who are trying to get Docker to production? Except for don't do it.
Don't do it. No. Just to be serious about this. If you want to build Docker in production, yes, it can be a good idea in some case. First, build a Docker in a virtualization each time. So each time you're using Docker, just have a virtual machine on around it, and be sure you will not be able to go outside of the virtualization. So the first thing is to, yes, use Docker, but one Docker per virtual machine is exactly what we do at Clever Cloud. If you push one Docker, you have it. The second thing is build it with your ops team, because you will need to update the whole operating system around it, and it will be very difficult, and it will be the best idea to do it. But really, I don't think it's a good idea for many cases, exceptionally for database, for example. Database on the container is a really bad idea. It will not end well, and you will lose data. And yeah, if you absolutely want to run Docker in production, like, okay, do it. But consider you have prevented that it will be harming.
Thank you.
More question?
Just quick one. Where to learn the dark magic of Linux? Was it the best book or source?
Excellent question. First, I will reply with the hard way to learn, but I think it's the best way anyway. First, if you're not using Linux every day in your laptop, do it. And I recommend 2 steps on this. First step, it's a distribution called Arch Linux, which is pretty well known. Not because it's the best designed, but because it will need you to learn some stuff to be able to run it. Okay? To be quick, it will break, you will have to fix it, and during the process you will learn. If you are familiar with Arch Linux, you can go to the step 2. There is another distribution we use at Clever Cloud called Exerbo, like this. And Exerbo is a source-based distribution who actually have been designed to make everyone be able to be contributor upstream to all Linux software here. And it's a very, very good distribution to learn. It's not user-friendly at all. But if you're using it every day on your laptop, you will break the system often and learn a lot during the process, which is great, which is why we're here. I don't think it's a good idea to run it on your laptop for user interaction reasons. It's a good idea to become a dark wizard on Linux. And the community is very friendly. Another point is to read. There is something called LWN, which is the Linux newsletter. And just subscribe to this, and you will have the resume of everything there. And I think it's a pretty good idea. And sure, there is the already book about Linux kernel. There is the big already. I don't know if it's still up to date, but when I was young, it was the best way to understand how Linux is working inside. It's basically part of Linux source code with comments. Boring, like boring a lot. But after I've read it, you learn a lot about that. Any more questions? Did you learn something about all Linux working during the presentation? Yeah? Are you happy to come to the presentation or not? Okay, cool. I take all the feedbacks. Don't hesitate to tweet me all the feedbacks. It would be great. Does you know Clever Cloud before the presentation? Maybe use it? Thanks! Use it. It's good. Okay, thank you very much. And grab some stickers.